I still remember the exact moment, almost to the second, when I first noticed something was happening with 3I Atlas that shouldn't happen to a normal comet.
We'd been watching it for months, tracking its brightness, its trajectory, the behavior of its tail, comparing it with every known comet, asteroid, and interstellar object in our catalogues. At first, it looked like a normal, albeit strange, interstellar body. Unusual velocity, anomalous maneuvers, strange ejections of water. But one night, as I sat in front of a wall of monitors waiting for the next batch of data from the telescopes, a curve appeared on the brightness graph that defied any classical model. 3I Atlas began to grow.
Not just brighter due to its proximity to the Sun, not just spewing more gas, but actually increasing in angular size, as if the body itself were getting larger over time. My team and I initially attributed this to a calibration error.
These things always happen. Incorrect exposure, noise, poor telescope positioning, atmospheric distortion, sensor defects. I asked to double-check the data from various observatories.
We pulled up archived images from recent weeks and compared them with new ones. And the more we compared, the clearer it became. This wasn't an error.
In each independent dataset from different points on Earth with different instruments, 3I Atlas occupied an increasingly larger angular size in the sky. For a normal comet, this could indicate the destruction of the nucleus and the expansion of the dust cloud around it.
But the spectrum didn't show classic decay.
Instead of a chaotic cloud, we saw a structured expansion, as if something beneath the shell was slowly unraveling.
At first, I told myself, calm down. You're a physicist, not a sci-fi hero. Find a banal explanation. We considered the possibility that increased solar heating was simply expanding the comatose cloud, gases and dust around the nucleus.
But the temperature and distance from the Sun didn't support this hypothesis. The object wasn't yet in a zone where such processes could occur so abruptly.
Moreover, the brightness didn't increase as a typical comet would. Instead of a smooth increase, we saw abrupt steps, as if the comet were switching between states. This was precisely reminiscent of a series of phase transitions in a system that operates according to an internal schedule, rather than being governed solely by external heating.
Then we looked deeper.
High-sensitivity spectrographs showed that as 3I Atlas magnified, not only the size, but also the nature of the reflected light changed. New scattering lines appeared that weren't there before, and some old ones evened out. It looked as if the object's surface was gradually becoming smoother and more uniform, as if something beneath the layer of ice and dust was straightening, redistributing, or even shedding its external irregularities. If you ask me how to describe it to the average person, I'd say this. The comet looked like it was peeling off its old, cracked skin, slowly preparing to reveal what lay beneath. One day, we received a series of high-resolution images, which I reviewed personally, zooming in on every section, every pixel, as if trying to catch the object in a lie. These images revealed something that made me step away from the monitor and simply stare at it for a while. The outer shell around the nucleus was no longer the fuzzy, round spot it should be for a typical coma, but was beginning to take on a slightly elongated, segmented shape, as if beneath it lay not a spherical nucleus, but some kind of structure. And these structures were gradually unraveling. I told myself it could just be a trick of the light, but the more data we received, the less room there was for self-deception. My team and I decided to approach this as a problem of pure physics. I asked them to simulate how a comet with an unstable nucleus would behave if it began to disintegrate. The models showed that as the nucleus disintegrated, fragments scattered, the cloud density increased, the trajectory became more chaotic, and its shape became more diffuse. But Atlas behaved exactly the opposite. As it grew, its trajectory became more stable, its tail more orderly, and its brightness less noisy. It didn't look like the object was dying. It looked like it was activating. One evening, as we were discussing this for the 10th time, someone in the room quietly said, "What if it's not growing? What if it's unfolding?" The phrase hung in the air, and I felt a chill run down my spine. If 3i Atlas isn't actually growing through decay, but is instead unfurling its outer shell, releasing its internal structures, then we're not dealing with a comet, but with an object that passed through our cosmic courtyard in dormant mode, and is only now beginning to wake up. The following weeks turned into a continuous marathon of observations. I remember sitting for hours in front of a panorama of screens updating with infrared data. The data included data maps, light curves, radio spectra, and the dynamics of water jets, which we already knew about. And at all these levels of observation, the same trend emerged. The scale and structure of Atlas changed in a coordinated manner. As the angular size increased, so did the water jets. As the shape of the shell changed, so did the nature of the electromagnetic fluctuations around the object. This didn't resemble chaos. It resembled a sequence of steps in a complex process, as if the object were executing a predetermined program, changing its state step by step. I don't like making sweeping statements without at least minimal statistics, but even the first figures here looked alarmingly logical. The shell's expansion didn't occur at an arbitrary rate, but rather along a curve that corresponded to an exponential function with saturation. In other words, at first the expansion was slow, then faster, and then began to slow again, as if the object were striving toward a specific final configuration. In engineering, such curves are typical for systems entering their operating mode. For example, when an engine ramps up power and then stabilizes. Natural processes rarely appear so orderly. But Atlas behaved as if its growth were not a failure, but a startup. I increasingly found myself saying she rather than it. Not because the object is conscious, but because it was beginning to behave as if it possessed an internal logic. We noticed how the tail's parameters changed depending on the object's orientation relative to the sun, not only passively, but also actively. Atlas was clearly trying to reduce the load on certain areas of the shell by turning them away from the solar flux. This again resembled the work of a system that strives to maintain its integrity, rather than simply blindly obeying external forces. At some point, my team and I stopped avoiding awkward terms. For the first time, I heard one of my colleagues say out loud, "If this were a ship, this would all make perfect sense." And it was at that moment that I realized our primary goal was no longer to prove that Atlas is a comet. Our goal was to honestly describe what we were seeing, even if it took us far beyond the bounds of conventional astronomy. And what we saw next only reinforced this feeling. The data included data maps, light curves, radio spectra, and the dynamics of water jets, which we already knew about. And at all these levels of observation, the same trend emerged. The scale and structure of Atlas changed in a coordinated manner. As the angular size increased, so did the water jets. As the shape of the shell changed, so did the nature of the electromagnetic fluctuations around the object. This didn't resemble chaos. It resembled a sequence of steps in a complex process, as if the object were executing a predetermined program, changing its state step by step. I don't like making sweeping statements without at least minimal statistics. But even the first figures here looked alarmingly logical. The shell's expansion didn't occur at an arbitrary rate, but rather along a curve that corresponded to an exponential function with saturation. In other words, at first the expansion was slow, then faster, and then began to slow again, as if the object were striving toward a specific final configuration. In engineering, such curves are typical for systems entering their operating mode. For example, when an engine ramps up power and then stabilizes. Natural processes rarely appear so orderly. But Atlas behaved as if its growth were not a failure, but a startup. I increasingly found myself saying she rather than it. Not because the object is conscious, but because it was beginning to behave as if it possessed an internal logic. We noticed how the tail's parameters changed depending on the object's orientation relative to the sun, not only passively, but also actively. Atlas was clearly trying to reduce the load on certain areas of the shell by turning them away from the solar flux. This again resembled the work of a system that strives to maintain its integrity,
rather than simply blindly obeying external forces.
At some point, my team and I stopped avoiding awkward terms.
For the first time, I heard one of my colleagues say out loud, "If this were a ship, this would all make perfect sense." And it was at that moment that I realized our primary goal was no longer to prove that Atlas is a comet.
Our goal was to honestly describe what we were seeing, even if it took us far beyond the bounds of conventional astronomy. And what we saw next only reinforced this feeling. The next turning point came when we began analyzing the rate at which the apparent expansion of 3I Atlas accelerated. For days, I stared at graphs slowly, as if lazily, rising, but suddenly, almost imperceptibly at first, the slope of the curve changed. The object began to expand faster, not suddenly, but with frightening smoothness, as if someone had turned a power knob one small but extremely significant increment. At such moments, I always tell my students, nature loves chaos, but technology loves smooth transitions. And here we saw technology, or at least something behaving like technology. As the envelope expanded, its reflective properties began to shift in ways that made no sense if the object were merely shedding material. Usually, when a comet gets larger because it loses mass, the distribution of the coma becomes uneven, forming turbulence and density gradients. But Atlas behaved like a structure that was smoothing itself, aligning its outer layers into a more coherent form. This suggested an internal skeleton or framework guiding the process. I remember sitting with my team in the dimly lit observation room, watching simulation after simulation, each one showing that the expansion could only be explained by internal support. Something beneath the shell pushing outward, methodically, progressively, intentionally. One of my colleagues, an expert in structural astrophysics, came to me almost trembling. "Michio," he said, "if this expansion continues following the current model, the object will reach a stable configuration in approximately 49 days. Stable. Not decaying, not collapsing. Stabilizing." His voice cracked when he said that, because stability implies function. Function implies purpose. And purpose implies something built, not born. In the days that followed, we paid special attention to the water that Atlas was throwing out. As the facility grew, the emission intensity also increased, but not linearly. She grew as a reaction to internal pressure. We hypothesized that if some structure were indeed unfolding inside, it would generate heat, perhaps even mechanical friction or electrical processes requiring cooling. And each increase in water emissions coincided with localized temperature spikes, which we recorded with infrared detectors. It looked as if the object was breathing, entering a new stage of activation. At some point, I realized that we were no longer dealing with astronomical curiosity. We were documenting a transformation. Something inside Atlas was awakening, and the shell, that dusty, cracked, frozen cloak, was nothing more than an old container breaking apart to reveal what had been hidden for perhaps millions of years. And I couldn't escape the thought that haunted me every time I saw new data. What if the object was waiting for this exact moment? What if this region of space, or perhaps our star, was the trigger it had been programmed to respond to? The idea seemed absurd until more evidence began to fall into place. As the expansion continued, strange oscillations began to appear in the electromagnetic halo around Atlas. They were subtle at first, faint fluctuations that looked like background noise. But then we noticed that these oscillations were repeating with alarming regularity. They occurred every few hours, as if the object were pulsating into space, checking the state of its shell or calibrating its internal systems. Their frequency varied depending on the degree of expansion, which reminded me of the behavior of complex machines running system tests during activation. I remember one evening sitting alone in the control center after the rest of the team had left. I turned off the lights, leaving only the glow of the screens illuminating the room. On the main monitor, the model of Atlas slowly rotated, no longer a blurred shape drifting through space, but something that now resembled a chrysalis in the final stages of metamorphosis.
And for the first time in my life, I felt not so much fear as a deep, primal sense that we were observing something never intended for human eyes.
We noticed another strange effect. As the object grew, the density of the dust surrounding it began to decrease. Not because the dust was dispersing naturally, but because it appeared to be settling back onto the shell in a controlled manner. Dust doesn't behave like that. Random particles in a coma move chaotically, pushed by solar wind and random collisions. But the dust around Atlas was falling into symmetrical bands, like iron filings aligning around a magnetic field. This suggested that the object was generating some kind of force, perhaps electrostatic, perhaps magnetic, perhaps something we have no name for, that was pulling its outer layer into a new, ordered configuration. Then came the moment I knew would change the conversation forever. The internal reflection was inconsistent with a solid, icy body. Instead of reflecting uniformly, the signal showed pockets of empty space beneath the shell, hollow cavities arranged in patterns no natural comet could possess. This meant only one thing. The interior of Atlas was not a solid mass of ice and rock. It was compartmentalized, structured, possibly segmented like rooms, chambers, or structural modules. I tried to steady my breathing as I read the printouts. Every instinct in me screamed that this was not a comet at all. It was a construct, an object, a structure passing through our system under the guise of a natural body. And then came the part that shook me the most. When we compared radar scans from 2 weeks earlier with the most recent ones, it became clear that the hollow spaces were shifting. Their configuration was changing as the object expanded. Chambers were moving, aligning, repositioning relative to each other, like components sliding into place. Units docking. Systems preparing for something none of us dared to say out loud. At that moment, I finally spoke aloud the words that had been hanging in the air for days. We're watching it assemble itself. And the team silently nodded. No one objected. No one tried to suggest another explanation. We all understood. Natural comets do not assemble themselves from the inside. The closer we monitored the internal restructuring of 3I Atlas, the more undeniable it became that whatever was happening inside the expanding shell was following a deliberate sequence. I found myself waking up in the middle of the night, replaying the radar echoes in my mind, imagining the hollow compartments shifting like gears inside an ancient machine. I kept asking myself, what system, what device, what intelligence could withstand the crushing emptiness of interstellar space for perhaps millions of years, only to begin unfolding now, at this exact moment in the history of our civilization? No comet behaves this way. No natural object prepares itself. But Atlas was preparing. For what? I did not yet know. We started detecting faint thermal pulses that radiated outward from the object's core, almost like heartbeats. They were slow, deliberate, and unlike any thermal signature produced by sublimating ice or geological fragments. These pulses moved through the shell in waves, each wave accompanied by a slight but measurable increase in luminosity. It reminded me of how certain artificial systems test their structural integrity. A controlled release of energy, spread evenly across a hull to search for weak points. Watching these pulses, I could not escape the impression that Atlas was checking itself, inspecting its own body the way a living creature might flex its muscles after waking from a long sleep. As the pulses grew stronger, the expanding shell began showing signs of segmentation. What at first looked like random cracks resolved into repeating geometric lines. Over time, they formed curved arcs and straight seams, many of them spaced at mathematically consistent intervals. One of my colleagues whispered that they looked like the outlines of panels. The comparison was impossible to dismiss. These were not fractures. These were joins. And joins imply construction.
I remember leaning back in my chair, feeling the weight of history press down on me.
If the shell was made of panels, then Atlas was not simply unfolding. It was preparing to open. The thought sent a chill down my spine.
Everything we knew about comets collapsed in that moment. The question was no longer whether this object was artificial. The question became something far more unsettling. Why was it activating now? And what would emerge once the shell completed its transformation?
The expansion eventually reached a phase where the rate of change slowed, matching the predictions of the logistic curve we had been tracking earlier. That plateau, that stabilization point, suggested that Atlas was reaching its final configuration. I watched in silence as the object's outline sharpened on the screens, the once chaotic coma now reorganized into a symmetric halo.
It looked like a chrysalis hardening into its final form. And then something extraordinary happened. The halo began to rotate independently of the shell, forming a spiraling pattern we had never observed before.
Dust and vapor circled the object in perfectly aligned bands, as if responding to an unseen magnetic lattice. One by one, global observatories confirmed the same pattern.
The halo wasn't just swirling, it was reacting. It was responding to changes within the object, as if guided by an internal field.
The realization hit me like a jolt. If the halo was aligning to a magnetic pattern, then Atlas was generating that pattern intentionally. In other words, Atlas had turned itself into an electromagnetic beacon.
But who was the beacon for? And what was it signaling? During one of our most intense observation sessions, the shell flashed. A brief, sharp glint that lasted no more than a fraction of a second.
At first, we thought it was a sensor glitch, but it repeated again exactly 41 minutes later. Then again, 41 minutes after that.
Regular, periodic, unwavering.
It was not a reflection. It was not noise. It was a signal. 3 identical flashes at perfect intervals emitted from the same point on the shell. Something inside Atlas was now transmitting. I felt my throat tighten as I watched the pattern burn across the graph. 3 pulses, then silence. 3 pulses, then silence. I had spent decades studying cosmic phenomena, but nothing prepared me for the idea that a structure disguised as a comet might be sending timed emissions. I whispered aloud without meaning to. "It's communicating." My colleagues nodded in silence. But the situation became even more bizarre when we overlaid the pulse intervals with the timeline of Atlas's expansion. The entire process, every increase in size, every water jet, every thermal surge, aligned with a single exponential progression, as though aimed toward a specific activation point. And then we found it. A projected moment just days away when the object's internal processes would reach equilibrium. It was as if Atlas had been climbing a staircase step by step, and now it was about to reach the landing. This realization spread through scientific circles like wildfire. Governments demanded classified briefings. Space agencies worked around the clock. Engineers tried to build models using everything from plasma resonances to metamaterial dynamics. Nothing matched the data. The trajectory simulations indicated that Atlas was still on its original path, unaltered, uninterested in approaching Earth. It was not coming to us. It was simply activating, here in our neighborhood, as if this region of space held some significance in whatever mission it was designed to perform. I remember staring at a simulation of the solar system, watching Atlas glide through the darkness. It wasn't deviating toward Earth. It wasn't slowing. It wasn't accelerating. It was just continuing. But now it was continuing in a different form. Not as a dormant shell, but as something fully awake. Then came the event that none of us expected. As the shell neared full stabilization, we detected a faint series of internal vibrations, measured through Doppler shifts in the reflected radar. These vibrations were rhythmic, They followed harmonic ratios, the kind that appear in engineered systems balancing internal forces.
I knew the pattern instantly. It resembled frequency cycling in energy conduits. In simpler terms, it looked like the object was powering up. The vibrations grew stronger for several hours. Then, in an instant, the object's luminosity dipped, not gradually, but sharply, as if a massive internal subsystem had suddenly come online and absorbed a tremendous amount of energy.
The shell cooled rapidly, its thermal signature dropping almost to background levels. The halo collapsed inward, forming a tight ring. Everything pointed to one conclusion. Atlas had entered a new operational state. And then, for the first time, we saw beneath the shell. A small section of the surface shifted, not cracked, not broke, shifted. The movement was subtle, like a panel sliding along a track. For a fraction of a second, a rectangular gap appeared, revealing a faint blue glow inside the object. That glow was not thermal. It was not reflected. It was generated, artificial, controlled, deliberate. We all froze. My pulse hammered in my ears. For the first time in my career, I found myself unable to speak, because in that moment, everything I thought I knew about the universe changed. Every assumption about cosmic solitude, about natural phenomena, about the boundaries between science and the unimaginable, all of it evaporated. I whispered, with a voice barely my own, "It's opening!" And the room erupted with a mix of awe, fear, disbelief, and something I had not felt since childhood. Wonder. Pure, unfiltered wonder. The shell shifted again. The blue glow intensified. Then the panel sealed shut, as if Atlas merely allowed us a brief, intentional glimpse, a preview of what was coming next. Since that moment, one question has consumed my mind. Was that a malfunction? Or was it a message? Because if it was a message, then whoever built Atlas did not just send a machine across the galaxy. They sent a signal to anyone watching. A signal that says, "We are here. We have awakened. And we know you are watching." And as I stand before the screens now, waiting for the next pulse, the next vibration, the next opening of that mysterious panel, I realize something that changes everything we are as a species. We are no longer observing a cosmic object. We are witnessing a transition. And whatever 3i Atlas becomes next, humanity will see it unfold, not as passive observers of the universe, but as participants in a story far older and far larger than ourselves.